Hello and welcome to Wiseman channel. Today we're gonna react on another video. This time is by Salvador Mendoza, or Salva, or Nexing, which is his username in the community, and is quite well known for payment systems and his research about it, and bringing a lot of hardware stuff to the community. I think it's gonna be an interesting talk. Let's get started. So it's his NFC payments, the art of relay and replay attacks. And this one was recorded in Hack in the Box GSEC in Singapore 2018. So it's a little bit older talk, but still very relevant.
So who am I? I'm a security researcher. I present about some flaws and issues about Samsung Pay 2 years ago. Probably you remember that. They still vulnerability. So also I present last year about exploiting mass information data with Bluetooth audio. And I proudly co-founded a Women in Tech Fund, which basically empower women to go to this kind of conference, security and technological. We're going to talk about in this tag how to spend money from other people. So everything about this tag is illegal. Just to let you know. Basically, how we can move a transaction from one place to another. That's the point. It could be relay, it could be replay. In this example, I'm making a small relay locally with a Raspberry Pi, moving a Samsung Pay transaction from the mobile device to another device, which basically behaves as POS.
All right, so the credit card reader on the right, this one here, I don't know if you see it, yeah, we should, is the payment credit terminal, and then this is his pay with Samsung. This is his credit card we're doing. So he has this Raspberry Pi up there, a Pico, and then, so this one behind here talks to his phone, goes over to that one, and then presents it here. All right.
So the idea of this tag is going to relate everything related to this kind of environment. It will be about what is NFC. We're going to talk about introduction, the process of the EMV, which basically is how the transaction goes through, fraud vectors from the banks, previous words from Peter Fillmore and Michael Rowland.
Peter Fillmore from New Zealand. That's a great PhD doctor. He is very famous about his EMV findings, and he's amazing when it comes to crypto knowledge. If you've been to his personal website, he has a personal website, and it's like this gigantic old style when it just drops all things he has done according to crypto, and it's like a gigantic guy in that one. It's like, wow, amazing.
NFC emulations, of course, replay or relay attacks. And also another topic that it's very interesting, how to extract chips data with NFC, which is not documented at all. Relay for replay attacks, a new attack, which basically is a smart relay attack. And how this can...
Smart relay attack, replay. Well, yeah, okay, I get it. Replay would be when you collect something, collect communication, you know, when you sniff traffic between a reader and a card, when you save that one, and then you would replay that against the reader, if that's what you want, or against the card if you want to replay it towards that one, of course. Relay is just sending over, like we've seen before.
Play or relay attacks will affect new technology to come. So basically, a NFC technology is a protocol that you need to get closer to another device to start the communication. And the NFC process is very straightforward. You need to approach the smart card to a terminal, and the terminal is going to give the power to the smart card.
Even you, Salva? RFID technology. I will die on this hill.
To boot up and start the communication. Basically, NFC is in the passive frequency, which basically is 13.56 megahertz. It's passive mode technology, which means that you need to approach to the terminal to boot up the card. It's well implemented in IoT, and we're using the ISO 14443A for this communication. Even when we have a lot of technology that use in NFC, we're going to be focused just in bank wallets. That's what I mentioned before. Is like the terminal started communication with the car all the time. People get confused a little bit.
So some people get confused about this as well, what I think he's going to say about it. So this is a smart card, chip and pin. When you have a chip with a contact, so this is called a contact mode. And this, when you go for the RFID part of this, when you talk it, it's called contactless. So it's two different modes of operation.
Bit about this, they thought that when they approached the car to the terminal, you start the communication, but that's not true. The first command comes from the terminal because it's waiting for the smart card. A little bit, what is a transaction you have to have in mind is like the terminal starts sending commands to the smart card, and the smart card is going to answer back. It's like when you're in the shell and you're typing commands, even when you type the right or wrong command, you're going to get an answer back. It's the same thing with the smart cards. In this case, the terminal sends a command, in this case, it's a Fitbit Ionic smartwatch, which answers back. With 4 commands, we can have a transaction ready to go. So what is the MFA flow for this kind of transactions? The terminal detects the card, and it boots up. It detects the applications, could be Visa, MasterCard, or any kind of card that you're using. You get the data, processing restrictions, some actions in the terminal. But after everything of this, the transaction has to be finished. It could be declined or it could be accepted, but it has to be finished. One of the interesting things about NFC is that they are implementing tokenization process. The tokenization process basically is when you have a physical card and you add to the Apple Pay, Samsung Pay, or Google Pay technology, when you add your physical information to these technologies, they are going to generate virtual credit cards, which basically is if someone intercepts this tokenization of this virtual credit card, they can use it just for one time. So it's more secure, and that's the way it works. So when you approach, for example, let's say Google Pay to a terminal to make a payment, in the payment network, we have another third company, which I call token service provider, which basically validates the token of the virtual credit card and relates to the physical number, and that's sent to the bank associated with. And after that, the bank is going to decide if the transaction is going to be declined or is going to be accepted. So we have 2 technologies for mobile devices. We have Secure Element for Samsung Pay, Apple Pay, and we have host card emulation for Google Pay. And we're going to have some difference between them. So basically, Secure Element is developed for more than 20 years. It's a smart card, restricted access, and self-encryption. Basically, what it does is like when you're making a transaction, the terminal sends a challenge to the Secure Element, and the Secure Element mathematically calculates it and sends back the cryptographic application transaction counter. On the other side, we have the host card emulation, which implements Google Pay. It's a new version of Android Pay. We have limited use keys, tokenization process, cloud cryptogram, and transaction risk analysis. Basically, what it does, for example, when you add your card to Google Pay, when validates the card, it downloads 4 or 5 tokens, which basically are virtual credit cards. So you can start making payments, and when they finish that pile, it downloads another 5 or 4 tokens. So the fraud vector and the NFC. We need to know that, for example, in the United States, all this research is about the United States. It could apply to other countries, but it's based on tokenization in the United States. We have low limits. Basically, in the United States, we have the limit of $50 for NFC transaction, when you don't have to validate with PIN or signature or anything like that. But if you think about it, we can...
touch and pay, I can think is, when you just beep, touch and go. I think that's what we call. And yeah, there's a limit to it, how much you can do in those. Remember it's not that popular in the States to do this touch and go. It's very popular in Europe and in my country. Just do that. And I think they raised the limit during COVID, so you can even do even more transactions like that. And when you run out of it, you have to put in your card inside the reader, so it can read the chip and pin. But my problem with that is I rarely use my card now, so I tend to forget my PIN number. Before I would never do that, but now it's so simple to pay with your mobile phone, my iPhone. It's just, touch and go, and that's it. Then you have your Face ID, and it's super simple. But it also means I've forgotten about my PIN number. I'm ashamed.
Grab $50 in the United States and move that $50 to South America, for example. And that $50 is going to be worth it in another country, let's say. We don't have additional card hold verification. For the brand perspective, the fraud is considered a accepted risk. And of course, we have NFC and many different IoT devices.
This is another thing I usually say to people when they ask me. This is all based on risk. The whole access control systems and payments, of course, it's down to an risk management. So how big is the risk and what is the worst case scenarios? And in banks, or when it comes involved with money, it comes to how much is okay. I don't know what Mastercard and Visa has, but it's more than a few $1,000,000 at least every year in fraud is quite much, and they think that's acceptable still. So just to give you a number to understand what a risk is for you and me as a private person, I mean, if someone steals $1,000, that would be that you wouldn't accept that as a risk, but still is there. To credit card holders or these big payment systems, the EMV systems, they have a different way of denote that. So you have to go from big business thinking to your personal perspective. Keep that in mind.
Which is going to be a problem. Attackers in the wild. We noticed that some guy was in the subway with a mobile POS trying to get close to people and try to make transactions offline. And it was documented in 2015. So the type of attacks well, I saw this one close in the United States, basically. It could be happening in other states, in other countries, let's say. Some previous work about...
Okay. So that means you all seen those when you read off access cards from people, you stand close to them in the bus or transport. The same thing applies to payments. If you weaponize a reader in the access control system, you can, more or less do the same thing, but with contactless point of sale systems, big antenna, and make sure that it's legal. And then you just stand close to them and the system does what it's supposed to do.
NFC. Dr. Michael Rowland presented about how to make replay attacks in MasterCard in 2013. Basically, what he found was that using the unique number 4-0, he reduced the possibility to guess or to have a better approach for the CVC. For example, in these 4 transactions, 3 of them were successful and just 1 were failed.
All right, so this is pre-calculating the CVC number, right? That's what you do. Unique number 4-0. All right, yeah, so he would pretend to be a reader with a proxy mark or something else, and then you would set the number to 0, and then you will calculate potential outcomes from it. All right, I think I read this paper. Good one.
Also, in 2015, Peter Fillmore presented in Black Hat about how he was able to move the turn the magstripe bit on and the AAP bytes inside of the APDU command. To move them, what he does basically was that when you have a level security in the NFC, when you reduce this bit, you tell the terminal to load the security in the transaction just to validate as magstripe information.
This is the problem when it's clear text communications and you can act as a man in the middle. Remember how you can do this file class when you do you block out a write, but it's more or less the same thing here. You just edit it out. I think it's basically what they said in the previous talk about relaying COs. It's the same thing. You just say that we're gonna use maximum waiting time. That's how it works. Same here.
That one was about software side. And the hardware side, Mr. Lee presented an NFC hacking the easy way and DEFCON 20 about how he can make 2 Android phones make a bridge between the smart card and the terminal. That was very interesting because, for example, you put a cell phone close to a smart card and another cell phone close to a terminal, and they can communicate using the Wi-Fi connection. For example, when the terminal send a command to the phone, and the phone sent by Wi-Fi to another phone, and the phone sent to the smart card, they were making a bridge with the transaction go back and forth between both of them. One of the limitations was the lagging depending on the network, but also some of the system that were implemented is no more available anymore. Also in DEFCON 25, some security guys, person for Rock Team, present these 2 boards, which were client and server, which basically is the same idea, using 2 devices, one close to the smart card and another one close to a terminal, and they start sending commands or making the bridge between both.
Hey, is that the Unicorn team from China? Could be. Always come up with interesting prototypes, right?
Of them. But the most important thing about this design was the SDR channel. Basically, the SDR channel, what it does is you add basically a specific channel to make the relay attack. So you are avoiding the delays in the communication, which basically is very important for the NFC communication. And we are going to talk a little bit more about that. But this project is a private prototype, and it's special design. When I noticed this...
Did he just brag that he got access to a private prototype? Oh, Salva. Why don't you share? Don't be like that. I want to know more.
This one is a 2.4 gigahertz SDR, which basically is for distance, but not to go in through the walls, let's say, for example. So let's talk a little bit about NFC emulation. NFC emulation is part of the NFC. Basically, NFC is divided in 3 sections. We have reader and writer, we have peer-to-peer communication, and we have emulation. Emulation basically is when you have a device that is going to act or is going to behave as a smart card. For example, I have this NFC reader, and when I turn it on, when I program it, I can tell it that instead of running as NFC reader, it's going to run an NFC emulator. So basically it's a ACR 122 based on the PM532, which basically I'm going to implement it with different devices which support this NFC reader. It's an open source chip, let's say in that way, for an HP company, that you can handle it with different commands to do whatever you want to do with it. For example, to initialize this device as emulator, you need to send it some kind of commands. I call native commands or APDU commands. The idea is, for example, when you send these commands, you are telling the reader that it's going to behave in that way. Of course, they are different kind of commands, and I started researching about them, how to send them to the NFC reader. But I found that Adam Lurie already has a GitHub with all the commands that I need to make.
Adam Lurie, major malfunction. There you are again. I'm not surprised. So this is the APDUs that you send to the reader chip, and the reader chip reads this and instructs it to do things. Okay.
The emulation process, which is pretty cool.
That's something that I usually get confused in the beginning, because you're always looking at different APDUs. Then you're like, oh, am I talking to the card? In this case, you're actually talking to a chip, the PM532.
Even he has a Python script that put the emulation mode automatically to this reader.
Wow.
So I was very lucky to find this before my research.
Never played with it though.
So let's talk a little bit about the replay attacks. Basically, replay attack is when you can get a transaction or intercept a transaction, and this transaction can go through in the terminal. Let's say, for example, that you are using Google Pay to make a transaction. Or let's say, for example, I'm asking you, can you show me how Google Pay works? And you basically take out your phone and start open your application and start making the transaction, but you're really not making the transaction, but you are using a token. and that token is still alive after you close the application. So I can intercept that token and use it later in another location.
Okay, so that's collecting tokens that is used, your virtual card, and there's no time to live. Is that what he's saying? So that token has a expiring timestamp. I wonder how long that is. So
I sent this flow to Google Pay this year. Basically, they respond, they accept it, and they assign the priority 1, severity 2, but it not qualified for reward. So after that, they told me that it won't fix it because it was intended behavior. What that means exactly? Intended behavior means that the payment systems works in that way. I mean, that kind of flexibility in the system could lead to make vulnerabilities in the payments.
So basically, the EMV is a standard of, I think it's over 6,000 pages. It's tons of documents that you can read and get your hands off. And I have not read it. I do know someone who actually did read it. I know a couple of people who've done that, and like Timur and Adam Laurie, but I didn't read it. And they tell me that things like this, what Sal was saying here, is more or less built. It's by design of a standard. So if you don't fix the standard, things like this will always exist. Scary, right?
It's already publicly reported about it. So basically, what I'm going to do here, I have a pocket chip connected to the ACR122. I have a Google Pay. What I'm going to do is I'm going to put the NFC reader in and first it's going to be a reader mode, which basically is going to read the token for Google Pay. So I'm going to intercept the token. I got the token, and after that, the same code is going to turn this ACR122 into emulation mode to make the replay attack. So basically, I'm using the square to make the transaction, and now it's validating the transaction, and the transaction goes through. So I got a notification in Google Pay that I make a transaction with Google Pay by basically I'm using another device to make the transaction, which is this one, $1.01. So the question here is, people tell me, but we're talking about $50. What's the problem exactly? The problem is that you not only are restricted to get one token. That's the main problem. The problem is that you can get more tokens than that.
Well, the question is, how many times can a token be used? Only once? How long does it live? A day? 1 hour? A week? No time? Because if it can be used several times, you can just spin up a whole heap of different payment systems across the globe and then send it out, and then you can take out $2 on each of them, and you'll never be above the limit of $50. And tick. I don't think that would work. But as you're going to say now is that you're going to collect a lot of tokens, which you can then replay everywhere. So when you pay for something, okay, the implication is if you pay something straight out of a box, someone can sniff out a lot of different tokens, send it somewhere else in the world, and make use of those as long as it's more or less than $1 or less than $50. Because, yeah.
So, for example, I can make it a program that starts intercepting tokens from Google Pay. I mean, these tokens are going to be alive for about, 24 hours? Who say that?
24 hours, okay.
24 hours approximately. So every token is different. You can see the IDs of the tokens. So let's say, for example, if I do...
But don't change very much in the token. It goes all the way down to 1502. Yeah, 57. It's not very much data that did change in those tokens, was it? Huh.
This kind of attack, I can get these tokens and make replay attacks for $50 in each one. This NFC project could be with different kind of hardware. This one is a PN
I guess everybody wants to know how to make tokens, right?
PM532, different one than the ECR122 that I show you, using an Arduino. Even you can use an external antenna to do that. This one is a Raspberry Pi connected to a $5 PM532 that could do the same thing. I mean, it depends on the malicious user how to interact with it. But I decided to make this kind of project. It's a Raspberry Pi Zero with ACR122. It's a LiPo, 3.7 volts, and a zero LiPo booster, which basically what it does is move the 3.7 volts to 5 volts. Basically, it's this kind of project. So we have a portable device. We have a reader and emulator simultaneously. We have Wi-Fi connectivity, and it's customizable. So let's try to play demo making a transaction. Basically, I have a Google Pay, and I'm going to run it as reader initially. And I'm going to intercept the token of Google Pay. After I intercept the token, I'm going to try to make a transaction using the same device. It's pretty cool, huh? Probably I'm going to design a better version of it. But basically, you need to think about these kind of tokens that are pre-validate them using the cloud cryptograms. That's why they can go through these kind of transactions.
Okay, that's why they work.
So after I got the transaction, I got the notification in Google.
Okay, now I get it. Okay. That's why those tokens, that's why you focus on Android Pay. Okay. So it's all validated, all pre-computed, and then from the cloud, and then, yeah, okay. So that's why you can replay it. Because we all okay. Yeah, that's nasty. That is just nasty.
I'm making a transaction with Google Pay, but I was using NFC copy project. So the relay attacks. Basically, relay attacks a more difficult feature, but we have the same idea. We need two devices. That is, one is close to the smart card, and another one is close to the terminal, a point-of-sale system. The idea is to have a fast device that could do that very quickly. If we think about the scenario, we have 10 centimeters in real world, how you can make a transaction, but the idea is how we can expand these 10 centimeters to hundreds of meters or kilometers. We have some inconvenience, we have some delays and timeouts in the NFC protocol, which basically each transaction has to be done in 500 milliseconds.
No, not NFC protocol. That would be the ISO 1433A and the ISO 7816 standards. But yes. So it's a limit of 500 milliseconds. All right. Payment terminal is not required to interrupt the transaction. That's sneaky.
But there is no restriction in the terminals to tell them that they need to stop the transaction if it takes longer. What that means is, like, for example, I can make transactions for 5 or 4.5 seconds without any problems. So this gives us chance to make relay attacks to the NFC protocol. So I designed this project I call Sentinelas, which basically is a Raspberry Pi with all the same hardware from the NFC copy project, but I add the CC1101 transceiver. What it does basically, why don't you choose the 2.4 gigahertz transceiver? Because this one is cheaper and it has different frequencies that I can work with it.
No.
We have low frequencies if I want to go through the walls, or high frequencies if I want distance for the relay. Also, we have different modulations. I'm using the default GFSK, and it's very cheap, $5 anyway. So basically, it's very straightforward connection. You can connect directly to the SPI protocol and the Raspberry Pi GPU, and you have two dependencies to turn on. We designed a small board so you can plug in the top of the GPU and connect the CC1101 Another limitation in the library of this prototype is that you can only send 60 bytes per packet. So, for example, if we have a APDU with 200 in length, we need to make chunks of this command. The idea of this is that the another node needs to know how many chunks are in the packet, and after it receives all the chunks, it can run the command in the terminal or in the NFC reader. So basically, we have two readers and emulators. We have Wi-Fi connectivity, customizable chip, and SDR support. So basically, this phone is acting as a POS terminal. I'm going to run the two programs using Python script, and you notice I already got the transaction. So you're going to see where is located the other device. The idea of this project is like how we can make something very cheap, and many people can do it basically to show how the NFC security flaws are there, but many people think that we need expensive hardware, but it's not true. So basically, there is where I have the another device, and here's the NFC card. What about LoRa? We have this technology that is coming up with a lot of distance. I was thinking about how make a relay with LoRa. So basically, I have this device using a Heltec board, which basically you have LoRa, Bluetooth, and another stuff inside the board. And this is the device, and I am on the other side of the building. So basically, you will see how I got in the transaction, implementing the same idea, using a phone as mobile panel system, and where is another device located. So the idea of this is that you can use different kind of technology to make this type of attacks. Another idea was how we can extract data from chip and PIN cards using NFC. Sounds kind of strange, but if you think about it, these two technologies share the same APDU layer. The idea, for example, if I send a command to the contactless card, if I send the same command to the contact card, it's going to answer somehow wrong or right, but we're going to have an answer. So we can handle the tags in the middle of the communication. We can extract data using the same kind of commands. So for this approach, instead of using the ACR in one side, I implement the USB smart card reader, basically using the same other devices to make the relay. Also, I changed the protocol, which basically instead of bytes or blocks and bytes, I mean using bytes in this case is T0 instead of T1. So let's show you a demo. So basically, I have a smart card reader connected to the Raspberry Pi using the SDR, the same one, and I have another device with the same device. This cell phone is acting as POS, so it's going to send the commands through the SDR, and the SDR is going to connect to the Raspberry Pi, and the Raspberry Pi is going to get the data from the card. So I'm getting the data from the chip and PIN card using NFC connection. Please don't use my numbers. No, it's already expired, so.
Not sure what that demo was in extracting the data there. It wasn't very clear. I think it was that he read out the chip and pin data, then the PAN number, and then printed it. So, didn't see that.
So let's talk a little bit about relay for replay. Relay for replay, I call it a smart.
Relay for replay. Oh, okay.
A smart relay. So the idea of this smart relay is how we can attack this kind of transaction when they are for secure elements. They call the more secure transactions in the mobile devices. So let's understand a little bit what happens here. In the first line, the terminal asks you what kind of technology is implementing. The Fitbit Ionic said, I'm using a Visa card. And the POS said, select the Visa card to see what kind of information it has. And after that, the POS sent the challenge. And the Fitbit responds with a cryptogram and the transaction, application transaction counter. And when it validates the cryptogram and the application transaction counter, the terminal sends to update the application transaction counter for the next time.
Wow. That's tremendously unclear. This is the hard part. For him, this is completely makes sense, looking at those bytes. And I actually recently met Timur as well. He's also into his EMV very, very well. And he can actually just look at it and go like, oh yeah, that's this. I, sadly enough, have not that same deep knowledge of APDUs and the EMV protocol in order to just identify by look like that, like they can. I would need some tools to sort it out, which I think one of these days will be made, but yeah, whatever.
So what happens if I intercept a transaction from the secure element and I save it and I try to replay it? Basically, when I'm replaying it, the terminal is going to send me the challenge. And if I send the saved cryptogram I already saved in my previous device, the POS is going to decline the transaction because it's not going to match. So let's think about it a little bit. When you add your card to the secure element, basically all the fields are going to be static for almost all the time. The only thing that is changing basically is the application transaction counter and the cryptogram. So if I can save a previous transaction and I make a relay, the only 20 bytes I need to send back and forward are the application transaction counter and the cryptogram. So I'm saving a lot of time in the relay attack.
True.
Let's say, for example, I have this saved previous transaction, and the only thing that I'm waiting for it is the application transaction counter and the cryptogram. So when the point of sale system asks me what kind of card you have, the first computer answers back because I already saved it, and the POS, until the POS sends the challenge, and that moment is when the first computer connects to the second computer, which is connected to the mobile device, and asks for the cryptogram or the challenge in this case, and this device is going to answer back, and that challenge goes back to the MPOS or the POS. And after that, you can have a lot of time to handle the commands. In this case, the relay attack.
Okay, so if you didn't get that, you basically let the device that talks to the point of sale reader. In shortcut it's like the other relays where you already repeat the anti-collision. You don't have to relay that part to the card. So he collected all the data he needed. And then the other device that talks to the card is more smarter and just extract, get transaction data and then just send that little string of 20 bytes instead, because that's much more faster. And given his example with LoRa and the RF version before, where you had these packages of 60 bytes, he now only needs to send one package. That's the advantage of it, and it's much faster in the timings when it talks to it. So yeah, I like it.
So you can improve the relay attack for about 2 or 3 seconds, which is pretty cool. And also this one gives you that you can have more distance for the relay attack. So basically, I have a previous save transaction from the smartwatch, which is Fitbit Ionic. And basically what I'm going to do is I'm just going to send the challenge, or get the challenge for the Fitbit Ionic, and it's going to send back that challenge, which basically in the middle there, and the transaction is approved. So the idea basically is that if you make a relay using a previous saved transaction, you can improve a lot your relay attacks. I mean, the malicious users.
And the reason why it works is, of course, it's clear text. So if you designers out there, take notes.
Yeah, after all, you can use this kind of technique to get a transaction. The guy is there, and there you go. Simplest way to do it.
Weaponize a reader. Take a Yanon reader and sneak up on people.
But it's very, very... So New technology. Basically, in the new technology, we have the smart cards. And they are implementing NFC to get into the cards, or to turn on the cards, or basically to do many things inside of the card. And we analyze the 3220 board, which basically is in the card. They are implementing NFC too. The question here is, if this kind of technology is going to have this kind of flaws, because even when we have...
Did he go over to car hacking now from pavement systems? Oh, that's interesting. That is really interesting. I know that relay attacks has been, using car hacking a lot of times. So, I haven't seen smart replay attacks though. Or I haven't looked so much into it. Interesting.
Some security measures inside of the NFC protocol, like timestamp formats and things like that, we are not implemented at all. So, new attack vectors. What about NFC and the web browsers? If you think about it, we don't have any library or support for the NFC and web browsers. Because
didn't Google Chrome add this web NFC? Not sure, I think. But did add a web USB, though.
It's very difficult. The idea of this library, web USB, is to be able to connect a NFC reader like this to the USB of the computer, and you can control it using the web browser. But many people is approaching incorrectly to solve this problem. For example, in Chrome, we have a experimental web platform features that you can enable to basically turn on the USB capability to connect directly from the Chrome to the USB devices.
Yeah, this talk is from 2018.
I start connecting, for example, this device directly to the computer, and I start trying to interact with it using the web browser. But it's very difficult because we don't have the manuals, we don't have all the information inside of the Chrome.
And it's JavaScript, the language of the devil. Yeah.
How it handles. But what this library has is that you can control Arduinos from the web browser. That means, I'm thinking about it, if I can control Arduinos, I can connect a board to Arduino for NFC, and I can do all the stuff for NFC technology. It's very straightforward. You have basically HTML file with a serial, which basically is how you're going to connect to the device. And you tell which kind of products you're going to be allowed to connect to it. In this case, Arduinos. Why Arduinos? Basically, some Arduinos because you can have full control of the USB stack. That's the idea. In the Arduino side, you have a...
This is kind of cool. Imagine, making your Proxmox client. Would be silly. Oh my god. Re-implementing that in web JavaScript and in for web browser. Jesus. Nasty.
A serial and they call a shell a little bit. Like a shell, when you can send commands from the web browser and the Arduino is going to run that kind of code. So the idea, for example, is I have connected an Arduino and it's going to act as a card. So basically, I'm sending a command from the web browser to the USB, and it's going to act as to make kind of a transaction with it. Some of the countermeasures that we can use for this type of attacks is a distance boundary protocols. These kind of protocols is very difficult to implement, even in mobile devices, because the mobile device can run many different applications that could take a lot of time.
It's even hard for dedicated readers to implement distance bounding protocols, which is, countermeasure to relay attacks in one way, or abusing timings. Cover that one in another one, in the other video. So yeah.
It's going to be difficult to see what's the timing between the transaction. But also we have timestamp formats inside of the NFC protocol that could be applicable, but it's very difficult to do it also. Also, another thing is that we can use an encryption and the NFC protocol that we are not implemented. Even if we can use, for example, the Felica NFC technology, that will be better because the Felica by default is encrypted. So some conclusion of this talk, an attacker doesn't need any specialized hardware to make fraudulent transactions. Even a mobile device could be used to intercept a transaction and to notice about the transaction, and after that replay it. Also, if the companies keep doing this kind of stuff, like in their products and designing, we are going to have the same flaws in the future. Please.
That was an interesting talk. I have to give him that. Wow. He's really into building and prototyping interesting gear. It's all off-the-shelf stuff as well. So, I mean, you can do it yourself and look into things. He used Adam Laurie's RF Idiot scripts for some of it. And then, yeah, this is a cool talk. He really got into relays a lot more. He did another talk later on when he did the replay, he called it, for the Proxmark. I need to look at that talk as well, because it's cool. Yeah. With that said, I hope you had a good time, and remember to read the datasheets.